And welcome to our chemistry video tutorial. Today we'll be looking at the concept of electrolysis, and this comes under what we call electrochemistry. So under electrochemistry, we want to focus on this concept of electrolysis. Before we begin with this, we want to know what exactly is electrolysis. This is going to be an exam focused video tutorial, so I'm going to be focusing on the basic thing you need to understand about electrolysis and the questions you probably may be seeing in your exams. So what is electrolysis? Electrolysis is the passage, this is the passage of direct current. Please keep in mind it has to be direct current. If you've ever seen something like DC, something like this DC, it stands for direct current. All right, not alternating current. So it is a passage of direct current through a compound, a compound. All right, in solution, or sometimes we call it molten form, with the composition occurring at the electrode. So we're not going to do a lot of explanation to this particular one because this video is focused on telling you the basic stuff, the definition, the formulas, and then calculations. So now we see this to be the definition of electrolysis. This, I need you to note that electrolysis occurs in a special vessel called the electrolytic cell. A special vessel called electrolytic cell. There's no time to draw those diagrams, but just keep in mind. So this particular electrolytic cell converts electrical energy to chemical energy. So that's one of the basic information I need you to be familiar with. The next thing I want you to know is what some of the used terms on this particular topic. One is the electrolyte. When you're asked to define electrolyte, just simply tell the person that an electrolyte is a compound which conducts electricity when it is in a liquid form. An electrolyte is a compound which conducts electricity when it is in liquid form. That settles for that. The next keyword you want to be familiar with, or terminology you need to know, is what we call the electrode. Now, what exactly is this electrode? Electrode is a terminal. Actually, they are actually terminal by which current enters and leaves the electrolytic cell. And there are two types of this particular electrode. That's the one they call the cathode. We have the cathode, and of course you can predict the other one immediately, anode, right? If that is in your mind, then you're absolutely correct. So this particular cathode is what we refer to as the negative. This particular cathode is the negative, whereas the anode is the positive. But there are actually conditions. It is only when you're talking about electrolytic cell that the cathode is negative. But when you're talking about electrochemical, this cathode is always positive. It's just an added information I've given to you. But what I want you to be familiar is that under electrolytic cell, cathode is always negative, anode is positive. But under what we call the chemical, electrochemical, just know that cathode is positive in that particular case and anode is negative, just the reverse of it. So take that down in your notes, it's very important. Now the next part we need to focus on is to talk about a specific law. I'm going to be giving you about two laws, but firstly we need to start with this one called the Faraday's law. Faraday's law, let me use first so you know the particular I'm talking about. Faraday's first law of electrolysis. What exactly is this law saying? It is pretty simple. This law states that the mass, we can use M like this to be the mass. Remember, mass in chemistry is always measured in grams. In physics, it's measured in kilogram. I need you to take note of that. Mass in chemistry is always measured in grams, but in physics is always in kilogram. So the mass of an element deposited, I'm talking about the first law, please write it down. The law of an element, the mass of an element deposited during electrolysis is directly proportional to the quantity of electricity. To the quantity, this Q here is for quantity of electricity. To the quantity of electricity. To the quantity of electricity. All right. So remember I said that the mass of an element deposited during electrolysis is directly proportional to the quantity of electricity that passed through the electrolytes. That's pretty simple. So here M is for the mass, Q is for the quantity of electricity. I'm going to produce a formula from this particular one. So if we say M is directly proportional, if we say M is directly proportional to Q, what this means mathematically, if we remove this particular sign, this proportionality sign, we are going to be introducing an equal sign, which M will be equal to K, then we have this Q. Look at this M is this one. Look at this Q is this particular one you're having. So how did we now get this equal to K? It comes from this particular proportionality sign. Whenever you remove the proportionality sign, you introduce an equals K. Okay, remember this mass, this is M. M stands for mass measured in grams. In grams. This particular one, which is the quantity of electricity, is also, it also has its own unit. The unit is coulomb. Please take note of it. Then what about this particular K? Because of this particular topic, electrolysis, we are going to replace this particular K with Z. We know that K is constant, but we want to switch this particular constant to Z. We want to use Z to replace this particular K and give the name of the constant, this particular constant. We want to replace it with Z and give a very unique name for this particular Z. So that means in that case, we can have this particular formula to become, or equation to become, M equal to ZQ. So what is this Z? Z is a constant of proportionality, and the name of this constant is the electrochemical equivalent. You can put that down. The name of that constant is electrochemical equivalent. Let me show you real quick. Electrochemical equivalent. So that is the meaning of this particular constant Z. Whenever you see Z in this particular formula, M equal to ZQ, just note that Z is standing for electrochemical equivalent. That is very, very important. But I want to still develop this particular formula. Remember, from electricity, current electricity, you are told that Q is equal to I. It has a formula, current times time. From current electricity in physics, you are told that Q is current times time. So that means in place of this Q, we can replace it with this one. You probably must have also seen this formula, ZIT, in this topic called electrolysis. If you've come across this formula, this is how it came about. Q, we know Q that it has a formula IT. So in place of Q, we replace it with IT. This Z is still this one, M is still this one. So this is another unique formula. I need you to be familiar with this formula and also be familiar with this formula under first law. What is this I? I is standing for current, electric current. And this I is measured in ampere. The unit of current is ampere. That means when you are calculating for current and you've gotten the answer for the current you're looking for, you must add this particular unit, which symbol is capital letter A, which is ampere. Also time, please note, anytime this particular T is standing for time, if the unit is not in seconds that I'm just showing you, if the unit is in minutes, make sure you have to convert it to seconds before using it to solve. If the unit is in hours, also make sure to convert it in seconds. By the time we start solving problem, I will show you how that is being done. So please keep following. If you've not hit the subscribe button, I think you should consider to hit the subscribe button, turn on that bell icon, so whenever I upload new video, receive notification. Please make sure to share this particular video after you're done and drop a nice comment if you're finding this particular video tutorial helpful. All right, so if you're able to get it to this point 1 and 2 and you understood everything I've ever said, that means you're making good progress. Do not forget what I said this Z stands for, because it always confuses a lot of students. That Z there is representing electrochemical equivalent. Now, as if that was not enough, let me also show you something that is very useful that you must know when you're dealing with this. And I can only show you that by solving a problem. So let's take the first question. Let me go on a new board. Let's see the first question. The first question I want us to look at is this. The question says, given the electrochemical, please write this question down. Electrochemical equivalent of a metal as 3.6 times 10 to the power of negative 4. I'll show you how to quickly solve problems in exams and have your answer. Now the question is, what quantity of electricity will liberate 20 grams of this metal if you're given F equals 96500C. You definitely must have been seeing this kind of stuff. Let me show you how these things works. But keep in mind, when you see F, this F is not for force. That F is standing for Faraday's constant, and that Faraday's constant has a value which is 96500 coulomb. Please take note of this F. It's not for force. All right, let's see the solution to this particular problem. Remember, I gave you two formulas. The first formula I gave you was M from Faraday's first law, M equal to ZIT. Remember this particular formula. It is very, very unique. Now, if you read through your question, make sure to bring out the data. What I mean by the data, I can as well call sometimes parameter. Those things given in the question. You can see that given the electrochemical, that means they have given you the electrochemical equivalent of metal. That means Z is what they meant by electrochemical equivalent. You're seeing how the dots are connecting. They have given you this Z to be this value which is 3.6 times 10 to the power of minus 4. Now, they say what quantity of electricity, that means Q. I told you before that Q is standing for quantity of electricity. We liberate 20 grams. That means they have given you, you could notice that the mass is given in grams, not in kilograms. That means we have your M to be equal to 20 grams. Very important, of this metal. Now, they also gave you this in case you may want to use this particular Faraday's constant as 96500 coulomb. In case you may want to use it, they provided that information. But let's see whether we will really need this particular one. Remember, anything given to you, that doesn't mean you must use all of them, all the parameters given, depending. So here from this formula, you can see that I is not given, current is not given, time is not given. It means this particular formula cannot fly. But from this formula, we can also deduce the other one. Remember, I have mentioned that Q is equal to IT. That means in place of this IT, I can replace it with Q. Now, Q is what you're looking for. Z is given to you. M is this one you're having. You can see that the problem is solved already. If I want to make this Q to stand alone, I would just simply divide both sides by Z. If I divide both sides by Z, this will cross out. So what is left is Q equal to M over Z. So how do we get the final answer? Q then will be equal to, the mass given to you is 20 grams. Please do not convert it to kilograms. Leave it as 20 grams divided by this value for the electrochemical equivalent, 3.6 times 10 to the power of negative 4. If you plug this on your calculator, let me do that real quick. The final answer you should have is 555.56 coulomb. If you have this particular final answer, it means you point your calculator correctly, and that is a very correct answer for this particular problem. Hope you found this particular one very helpful, and you're grabbing the particular concept we're trying to communicate. But that's not all. They can also tweak the question, bringing something differently from what you've been taught under first law. Look at it. But before you need to do that, before we need to solve another problem, I need you to be familiar with this second formula. This is the next formula I want to introduce to you, apart from the first one I introduced. You should be able to know that mass equal to, especially some of you preparing for JAMB exams, you should know this one. If you're preparing for GCSE exams, this will also will be very helpful. So molar mass times IT divided by Q times F. All right, all of these things looks crazy. Let's define each of these parameters. What are these things representing? What are they all about? If we're able to know this particular one, then we can be able to solve problems applying this. But I can tweak this formula in different way depending on the nature of the question. Let me show you real quick. This particular I you're seeing here, of course you can predict this one without me saying. What do you think the I stands for? Can you mention that real quick? Put it in the comment section. What is I and what is the unit of I? Do that real quick. You are absolutely correct. If you mention current, electric current, if you mention current or you mention electric current, then you're correct. And the unit is ampere, like I mentioned before, which is capital letter A for this. Now, the next thing we're having there is time. Time is in seconds. T is standing for time, and time is measured in seconds. I've always said that if time is given in minutes or if it is given in hours, please make sure to always convert it. Now, what about Q? We are seeing small letter q here. This particular Q is standing for charge of element or ion. Charge of element. If you're given a charge on an element or an ion, that's what this Q is standing for. Then F, of course, I've mentioned it before that F there is not for force. It's actually for Faraday. Faraday has gotten a lot of constant in different particular topic that he has contributed in. So this is Faraday's constant, and the value is 96500 coulomb. Whether it is given to you in exams or whether it was not given to you or it's not given to you in exam, please be familiar with this particular constant. It's actually a constant. Take note of it. It is very, very important. Okay, with this being said, can we be able to see how to solve? No, let me introduce another formula for you. There are some points where this particular equation 1 could be transformed, where instead of having this IT, they may replace this IT with Q. So you'll be having mass equal to molar mass. Oh, I've not talked about this molar mass. Molar mass is actually this molar mass. Of course, it is written clearly. This is standing for molar mass. If I had used capital letter M, then I think I would have listed it. But this is molar mass, and it is measured in grams. The unit of molar mass is gram per mole. Please take note of it. Gram per mole is the unit of molar mass. In case they didn't mention molar mass in a problem, and then you're seeing gram per mole attached to a particular number, just know that they are talking about molar mass. So when we have molar mass times, in place of this IT, we replace it with Q. Remember, we always say that Q is equal to current times time. So we decided to substitute Q for this particular IT and then still divide it by the Q times F. Every other meaning remain constant, but this particular Q here is not this particular Q. This Q now is talking about quantity. It's talking about quantity of electricity. Q here is standing for quantity of electricity. And this quantity of electricity, of course, is measured in coulomb. Please take note of this. This is very, very important. Now, with this being said, can we be able to see a problem? Let's solve a problem using all of this information we've gotten. Remember, sometimes we might need to make this guy the subject of the formula, either this Q or this one or any of these parameters. I will show you that real quick. Let's move to the next board, so I will show you how to make use of these things. It is very important. Now, let's see this question. Question 2. The question says, what mass of gold is deposited during the electrolysis. Please take down these questions, it's very important. Electrolysis of gold. They mention gold 3. Please pay attention to all this little information. Gold 3. Tetraoxosulfate. Tetraoxosulfate. 6. When a current of 15 ampere is passed for 193 seconds, then they have given you the molar mass of gold to be equal to 197. They have given you the molar mass of gold, which is 197. Let me add the unit, gram per mole. The unit is not added here, but let me just add it so that you know that it's for molar mass. Now pause this video and see if you can be able to provide the solution to this particular problem. What do you think will be the solution? But keep in mind, I have always tell you guys that whenever you're given problems like this, the first thing that comes in your mind is to fetch out the data. Fetch out the data, the parameters given in the question. If you look through this particular question, you will notice that molar mass is given. Molar mass of gold is given as 197 gram per mole. What again is given? Did you also notice that the current is given? Current is given. Let me just use I instead of writing everything in full, as 15 ampere. What again do you think has been given to us? Passed for seconds, that's the time. Did you also notice that the time is given as 193 seconds? It is in seconds, so we do not need to convert it. But if it were to be in minutes, or if it were to be in hours, then we would have converted it. Now, there's another one mentioned here, gold 3. Gold 3, that means the charge on the element. This is where this Q comes in. The charge Q, they mentioned that it is gold 3. Gold 3. That means if you're presenting it symbolically, you should be having AU for gold, then 3 plus. That's what it means. So it means that at this point, that our Q will be equal to this particular charge on this ion. That particular charge you're having there, which is 3. That's how you can be able to figure out your Q effortlessly. And of course, you know that F, in most cases they will give you, if they didn't give you, know that F is Faraday's constant, and that will be 96500 coulomb. So what exactly are you asked to find? That's what you have to figure out. They say what mass of this, so that means you're looking for the mass M. That's what you're looking for. Now looking at the whole of these things, you could see that the formula that could help you to figure out this was the formula I gave you, which was M was for mass equal to molar mass times IT divided by Q times F. So just plug everything into the formula, then you're good. The molar mass is already 197 multiplied by I, which is for current, is 15. Multiply that by T, which is for time, and that is 193. I hope you're finding this helpful. Divide that by Q, which we've gotten that to be 3, times F, which is that, you can see that where F is useful now, 96500. So imagine I didn't fetch out this parameter. I would be confused. I wouldn't even know the particular formula to use to figure out this. So how do I get my final mass? My mass will now be, if I multiply everything I have on the numerator and then divide that by the one I have on the denominator. Please try and do that real quick. Let me punch on my own calculator. 1 second. Yes, the final answer is 1.97. Mass is measured in grams. I've always said that. In chemistry, mass is always in grams. And this is the final answer to this particular problem. This kind of question, you definitely should be expecting it in your JAMB exams and also your GCSE. Depending on the exams, even if you're in the 100 level, sitting for chemistry exams and you're dealing with electrolysis or nursing school, then you should pay attention to this kind of question. It's a bit tricky, but straightforward and very simple. Let me solve another question under this particular one. Let's build your capacity and your understanding very well. So question 3, the question says that what current in amperes will deposit 2.7 grams of aluminum in 2 hours. Let's take the molar mass of aluminum to be equal to 27 gram per mole. All right, now this is another beautiful problem. Keep in mind, if you check this, you can use any formula of your choice, any particular formula that works for you. Remember, what you're looking for is a current. You're looking for the current, and the mass is given to you as 2.7 grams. And then of aluminum, they've given you the molar mass. Let's use capital letter M sub 0 as our molar mass instead of writing it in full like that. Gram per mole. Remember, this is 2.7. All right. Okay, so the time is then given in 2 hours. Please, let's convert these 2 hours to seconds. How do we do that? It's pretty simple. 2 hours should be converted to seconds. Very important. So therefore, we will just have the time to be 2 hours. 2 hours times 60 minutes. 60 minutes makes 1 hour, and 60 seconds makes 1 minute. So if you convert this, if you multiply the whole of these things, then you should have 60 times 60 should give you 3,600, if I'm not making mistakes. If you multiply that by 2, you have 7,200. Please use a calculator to be sure of this particular answer. This is our new time that I have just converted. This is the new time. Okay, so now if you pay attention to this particular question, you notice that aluminum always have its charge to be +3. That means Q will be equal to Al plus 3, which means that our Q is equal to 3. Aluminum always have the charge of 3. So that's why we have this one. So having presented all these parameters, it means that it is crystal clear that you're going to fall back to that particular formula. But then, what you're looking for is a current. You're looking for the current. It is no longer the mass. So that means from this particular formula we have mass equals, I would derive it, no worry. I would derive it for the sake of learning so that people will not, I would have quoted the formula straight up, but people will ask me, how did you get this? How did you get that? I want to explain everything in detail so that you don't have any form of confusion in this particular video tutorials. So in this case, remember, I want to make this I, the subject of the formula. How do I achieve this particular thing? It's pretty simple. First thing I will do, I will use this one. Let me change the ink. I will use this guy to multiply by the mass. So if I cross multiply, I will have mass times Q times F. Of course, if you know that this multiplied by this, what will be left on this other part is molar mass. Let me use capital letter M naught, like as I did here, for molar mass, times I times T. Now remember, I'm making this I the subject of formula. I have to divide both sides by this M naught, which is the molar mass, and this particular time. I will divide both sides by the molar mass times time. So this will cross out this. This will also cross out this, leaving us with I. So that means our I, which is the current, is the mass times Q, that is the charge, times F, the Faraday's constant, divided by the molar mass times this one, which is what? The time. Please, let's write that nicely. Okay, so you can see the new formula that we've coined by making it, we got it from this particular original formula, making I the subject of the formula. In this case, you just need to plug in all the parameters inside of it, and then you're good. You're good. because the question says what current in this. So just plug in everything. The mass given in this particular question is what? Guys, let's say it very quick. What is the mass? Look at it. The mass is 2.7. So you have 2.7 times Q is 3 times, of course, you know this guy is always 96500. That is the Faraday's constant. If you divide that by molar mass, the molar mass is 27. So 27 multiplied by the time. What is the time? 7200. We converted the time from what it was given to hours to seconds, and that's what we have in this. Okay, so by the time you are able to get to this particular point, you use your calculator to compute everything. Multiply this 2.7 by 3 by 96500, have your answer, then divide it by whatever it is you have for this 27 times this 7200, and then you may have 4.0 or just 4 ampere. This A is standing for ampere, which is a unit for current. So either have it as 4 ampere, let me write it in full, or you can put it as 4 ampere, which is the value for this particular current. Pretty simple, right? Okay, so the last aspect of this that I'm going to be showing to you, please make sure to like this video and share this video. It's very important, and make sure to subscribe if you've not hit the subscribe button. Turn on that bell icon and select all, so that by the time I upload new video, you receive notification, because I'm going to be posting more. All right, let me show you something real quick. Now, from this same formula, you should also remember that, let me put the formula first. From this same formula that I've shown you, there are a lot of things I will be exposing you to, so that you'll be very, very good on this particular topic. And this might be the part 1 of this topic. Of course, if you need the part 2, I will still request that you say that in the comment section, so that the video may not get so long more than what I intend to stop it. Okay, so remember, when you get to this point, I also have to let you know that Q is the same thing as this guy, IT. So what that means is that in place of this IT, I can still put this. I showed you this particular one before. Let me use M sub O to be for our molar mass times Q, which is for this IT like I just showed you. And we have Q times F. So what if you're asked to make Q the subject of the formula? If you have to make Q the subject of the formula, what do I need to do? It's simple. Just simply cross multiply this to this mass. So you have mass, I'm going to show you step by step. Mass times Q times F equal to molar mass. Remember, I say I will write molar mass like that, times Q. So if I divide both sides by this molar mass, divide both sides by this molar mass, then molar mass will cross out. Therefore, Q will be equal to mass times Q times F, Faraday's constant, divided by the molar mass, or that M sub naught. Now, pay attention to this particular concept. It is very, very important you understand this. With this particular understanding, do you know that under the stoichiometry, or the concept of mole, you have been told, I've also made the video. If you've not watched the video, just enable to go watch stoichiometry video. So number of mole is equal to mass. You should know this, mass all over molar mass. Let me use this particular representation, and you can see mass over here. You can see molar mass. That means mass over molar mass here represent N standing for number of mole. So I can still bring down this formula to be Q equal to, in place of this 2, which is mass over molar mass representing N, I can put N here times this particular Q times this particular F. That means I can also have Q to be equal to NQF. We are still talking about electrolysis, and so many of you have not seen this particular formula in electrolysis. Probably must have seen all these ones I've been doing, but you don't know that we can still derive to get this particular one. And now that they have gotten this particular one, can we use it to solve problem? Let's use this particular one to solve problems. So let me show you how it works, so that you don't mess up during exam. Okay, let's move on to this question. What is the question we need to use it to solve? Let's bring up one question. That's question 4. This question will say that you should calculate the quantity of electrolysis, or let's electricity, let's put it like that, the quantity of electricity required to discharge an electrode containing 4.0 mole of Q3 plus. Now this is very simple. This question is pretty very simple. Let me show you the solution to this. Now the first thing you want to do is to bring out the data, but I need you to recall first that I mentioned something like this, that Q is equal to NQF. This is the formula we're going to be using. How? See the data. Look at the data. The data will show you. It will expose everything to you. They say you should calculate the quantity of electricity. Remember I told you that Q is standing for quantity of electricity, and that's what they say you should calculate. Required to discharge an electrode containing 4.0 mole. See, number of mole is equal to 4.0 mole. And then this small letter Q, they have given you the charge. Look at the charge here, which is 3. And this guy, I've already told you that F is constant, which is the Faraday's constant, have 96500 coulomb. Do you now see that you can plug everything into this formula? Then you have the final answer. N is 4 times Q, which is 3, times this Faraday's constant, which is 96500. So by the time you multiply these things together, you should have about 1158000 coulomb. Remember, this quantity of electricity is measured in coulomb. This is very, very important. This is pretty easy. It is easy to follow, and I am sure that you're enjoying this particular video tutorials. Don't forget all the concept of mole, because we can equally manipulate the formula in different form to get exactly what we are looking for. So, but then I believe that these ones I have introduced to you have or should help you to a great extent. Then in the next part 2 of this, I'm going to be introducing the second law of electrolysis, the formula, and then the calculation that involves this particular one. If you share this particular video, I see a lot of shares, I see a lot of likes, I see a lot of comments, and then I saw that you've also subscribed to this particular video tutorial. That will give me a signal that you really need the part 2 of this particular one. And trust me, I'm going to do that for the sake of you passing your examination. So until next time, I'm going to see you. Thank you so much for watching this particular video. My name is Instructor Allison, the math and science video in both Pidgin English and plain English. Until next time, I'll see you. Peace and love.